let's get started. So in the next around 40 minutes, I will give you a brief introduction about some of the more advanced topics in TypeScript. So short introduction to myself. My name is Christian. I've been working as software engineer for like 14 years, started with Java and then switched over to more of a full stack role like 7 years ago when Angular was released. I then started also working heavily with TypeScript and JavaScript. Yeah, you can visit my website if you want, type.rocks. There you find the GitHub link to the talk that I will show you today. So all the code is on my GitHub, so you don't have to like take pictures. You can, of course, but it's not necessary. And yeah, I also do some trainings on the side for Kotlin, Java, TypeScript. And yeah, I really like to be at conferences, speak a little bit about TypeScript, about Java, and also, of course, like to listen to other speakers. So if you have questions, you can ask them all the time. Just go to type.rocks/QA. There is like the QA page where you can enter your question. At the end of the talk, we will then answer them. And if we don't have enough time, then I will just answer them later. So you can always come back to the page and you will see the questions answered. All right, so let's already get into the code. So we will talk about 6 topics today. And the first one we'll talk about are mapped types. So I was sitting in the back there, so I saw that you only see like the upper half of the screen, so I will try to focus on the upper half so that the ones in the back can really see it. So let's say you have a type events here. And let's say you have an add property and you have a remove property. So let's now say you have a user actions object. And now you want to have an on event for these events, so an on add and an on remove. So you say on add and you have a function and an on remove, which is also just a function. Now, how could you create such an on event type? Well, basically you could do the following. You could say, okay, we would say we have an on event here and we have our strictly typed function which takes anything and returns anything. And we do basically the same here, like this. Now, the problem with this approach is that if we add something to the events, that this will not throw a compile time error. And so, for example, if I add move here, then everything still compiles, but we don't want that because we want that if we change something in the events, that it also changes, that we also have to implement it in our user actions. So to fix this, we can use mapped types. So how can we do this? Well, first thing, we have to check, okay, what do we really want the keys to look like? We want the keys to look basically like the events, but with the on prefix and the uppercase first letter. So what we do to start with, we say we have an event keys here, and we say key of events. Basically, this creates a new type, which only allows add, remove, or move as its keys. So what we now can do is, we can now go into our on event and remove all our static types and can use a mapped type. So we can say, okay, the key has to be in event keys. So we can restrict this to these keys and we can say the value basically is a function. Now we can see that this no longer compiles, of course, because what we need to do here is we need to call this add and remove. And now we see that we get a compile time error because the user actions does not have this move property we have defined. So I have to add this here. And now our code compiles again. Now the problem, of course, still is we now have lost this on prefix, which we really want because we don't just want it to have the same names. And this is where we can use the map types and use our template literals. So we can say as here and use backticks like you would do in normal TypeScript code or in normal JavaScript code. And what we then can do is we say we want an on prefix, and now we can use template literal syntax like you would in normal JavaScript code, and we can then access our key. And what we now can do here is we can just go in there and say, okay, we want to have an on property, an on prefix, on remove, and on move. So now we are almost there. We have already this on prefix, and now we only need to capitalize the first letter of this key. And how can we do this? Well, basically, we just say capitalize, and we can see this is a so-called built-in type from TypeScript. So what this does is, if we pass it our key, we now need to uppercase all of our properties. And now we have the exact same as before, but with the one difference that if I change this here, for example, to delete, then we can see here we get a compile time error, and I have to change this to on delete to make it compile again. And of course, you are not just restricted to capitalize. You can also use every other type function, also ones that you define yourself. But one interesting part about this is if we check what kind of type this is, we can see this is a so-called intrinsic type. This means this is done by the TypeScript compiler, and it's not shown to us how it's done. And there are many such functions because it's done right inside the compiler to make it fast, but it's not shown to us how TypeScript exactly does this. So we have now taken a look into this template literals, but let's take a closer look to it. So let's go into the template literals. So what you can do with template literals is basically, let's say we have a chessboard here, and you want to have every possible position on a chessboard. Now what you could do is you could say A1, A2, and so on. You could do this 64 times. But of course, the problem is you could maybe miss one position or something like that. Now we can let these template literals build the combinations of our letters and numbers. So what we can say here is we have our chess letter, which is either an A or a B or C and so on. And we have our chess number, which is either 1, 2, or 3 and so on. And now we can say we have our chessboard, and we use backticks again to tell TypeScript this is a template literal. And we can now say, okay, the first one is a chess letter, and the second one is our chess number. And what this now does is it creates every possible combination between the letter and the number. So if you want to add, for example, more letters, we can just add it there, and we don't have to like check if it's added in every possible for every possible number, because TypeScript does this for us. Now, of course, you don't really need such a chessboard that often, but what you maybe need is to narrow your string types. So what do I mean with this? Let's say we have an RGBCSS type here, which is just an alias for a string to start with. Now, let's say we have valid RGB of type RGBCSS, and we say RGB 255, 0, and 0. And we can see this is a valid RGBCSS. IntelliJ picks this up. But what happens if I now say I have an invalid RGBCSS and I remove one element? Of course, IntelliJ doesn't know that this is not correct, but we don't get a compile time error. Now, how can we fix this? Well, basically what we do is we remove this string alias and we say we use template literals and do basically the same what we have done prior with this on prefix. We say we have an RGB here with parentheses, and in there we only allow numbers like this. And now we can see we get an error on line 5 because this does not satisfy this constraint we've put into our RGBCSS type. So, and TypeScript is clever about this. If we, for example, change this, if we change this to an A, we get an error because an A, of course, is not a number. So it checks if it's a number or if it's a string, and I would have to change this to string to also make this compile again. Now, we can do with the map types and the template literals, we can combine these and make really powerful types. So let's say we want to create like a small CSS validator. So we have a gap type here, and this is either margin or padding, and we have our gap position, which is either left or right, right or top or bottom. Now we can, of course, use the map type to create a combination of these two. So we can say we have our gap CSS, and this is now with backticks again. We can say we have our gap type, and followed by our gap position. And this, of course, creates every possible combination from margin and padding. So you don't have to create them yourself. But sometimes you also want to allow a margin and a padding on its own without a suffix. So we just add gap type here. And then it also allows only margin or only padding without the suffix. By the way, just a quick side note, this question mark here that it works in IntelliJ. This is a plugin I've written. It's called WIT. You can find it on the IntelliJ plugin marketplace. You can download it, and then you can just use a comment and point to a type, and it will show it to you. It's really nice if you're like working with your types and you don't want to hover over it all the time. But now let's say we want to do the same with the size. So we have our size type, and this is either rem or pixel or let's say percentage. And now we can say we have our size CSS, and this now is again with the template literals. We say we have a number followed by the size type. And what this does is basically we say we want to have a number as a prefix and then either rem, pixel, or percentage as its type of sizing. And now we can create a map type again. So what do? We say we have our type margin padding, and we can say our key has to be in gap CSS, and our value has to be size CSS. And now if we check, we create such an object, margin padding. The first cool thing about this is we have auto-completion. So for example, if I type P, we can see I have auto-completion for all possible keys. And of course, what I also have is for the values, we can see if I write the correct size, then everything compiles fine on this line. If I remove something, I get a compile time error. Now, maybe you've seen we got an error here on line 15. This is because here in this mapped type, we basically tell TypeScript, listen, we want an object with all the possible combinations for margin and padding. And to fix this and tell TypeScript we want to be able to pass in only certain properties, we just add a question mark here. And this way we tell TypeScript, listen, some of these properties might not be set by us. So let's now go a little bit into the never type. So the never type is something which maybe you have seen in some code, but often it doesn't seem that useful because you think, well, why should I use this? So let me show you how you can make your code, in my opinion, much more safe, runtime and compile time. So before we go into this, I have to show you something about conditional types. We have seen this prior, for example, with this capitalize, where we put in a type and received a new one. So let's say we have a Boolean or else string type, and we pass in any type we like with a generic. And now we can do some pattern matching. For example, we can say, okay, if t extends Boolean, in this case, just return Boolean, otherwise return a string. So in TypeScript, you cannot use like an equals because types are always inherited. So for example, you can't say t equals Boolean because you always have it can always have more in it. For example, if you have an object with a and b in it, it can always have the property c, and so you cannot say it's exactly the same. But what you can do with this is, if we call this, and for example, we have here our string, then we can see here that we get back string. If I change this to true, we get back a Boolean because true is like a subtype of Boolean. And how is this useful? Because with this you can use this like functions in normal pseudocode where you can put in something and create new types from it. Normally in JavaScript you will create like a new object or a new property from it. In TypeScript types you only create new types from it. So, but how can we use this? So let's say we have a function fail on empty string. We pass it in a string, and we say, well, if the input length is not set, we want to throw new error, and we say input is empty. Now, this is all fine, and if I pass this and I run this code, we will see that we get an error. Now, the problem with this is that this is only like a runtime error. So you don't see that you are not allowed to pass in an empty string at compile time. So you always have to have this throw error to check for runtime safety. Now, we can make this also compile time safe by creating a new type. And let's call this type never on empty string. And now we say we pass in a type and we say, okay, in case of t being exactly an empty string. So we say if something is passed in and it is exactly an empty string, in this case, we return never, otherwise we return t itself. Now, let's use this in our function. So we have our function here, and we first have to pass in like this generic. So we pass in this t, which we say extends string, so we only want to be allowed to pass in something of kind string. And now, instead of passing in only a string, we say never on empty string, and we pass in our t. And now we see here, we get a compile time error, because for the ones in the back, it says argument of type string is not assignable to parameter of type never. Now, what does happen here basically? We put in this empty string here. This empty string is this t, which gets passed into our type, and then this type checks, okay, is this type we pass in exactly an empty string? Yes, it is, so I return never, otherwise return the thing you got back. Now, and this basically resolves to this, to never. Now, but why are you not allowed to assign string to never? Because never is its own type system. So let's say we have here hello, which is a string, and we have hello devox. Now, if I say here, this is not a string, but never, then it tells you, okay, you are not allowed to assign string to never. Now, normally, you could fix this by saying as any. But even any is not assignable to never. So never is really used in these cases where you say, if we reach this point, first, basically we should never reach this point, but if we do, there is no way another type is assignable to never. So you can use this to like create an environment where you basically should never be in, but if you are in, then you can really be sure that you are not able to assign a type to something else. Maybe it's a little bit hard to understand, but I will show you something which I think will ring some bells. So let's say we have a locations here, and this is either Zurich or it's, let's say, Paris. Now we have a function get country for a location. Now let's say we pass in a location, and we want to return a string. Now, what we can do here, you can also do with if else, but I like to do this with a switch case. So we say we pass in a location. And now what we can do here is, okay, I say Paris and I say return France. And we of course now get a compile time error because TypeScript tells us, well, you have this Zurich branch, but this is not covered in the switch case, and if somebody passes in Zurich, then we'll just return undefined. But you say you don't want undefined, you really want a string back in all cases. So what we have to do is we add Zurich in here and say return Switzerland. Now you can call this now and all is fine. But the problem is, so if I call this with Zurich, as we can see here, we get back the result. Now the problem is, if you are, for example, a library author or somebody is passing you a string or which is as any, for example, you could also say you pass in London as any. Now, because TypeScript is only valid before the compile time, because after compile time it's just stripped away. If you run this, we get back undefined. So, and sometimes you don't really want this behavior to be even possible, because if it's in some kind of code, it's in your code, and you don't want to go further, what you really want to do is say add a default case. So we have a new error here which is thrown, and we say location is not known. But what now happens is, the problem is now you have the runtime safety. But if I now go back into my code and I think, oh, well, okay, maybe I want to support London, I can go in there and say, okay, I have now London as a location. But the problem now is that I have lost the compile time safety, because these cases here don't include London, but TypeScript tells you, okay, but there is this default case which catches everything which is not covered by the cases. So maybe the developer wants this to go into this default case. But we really don't want that. What we want is that we have the compile time safety also. And how can we do this? this is where we take the never type again. So what we can do is we create here a new variable, and let's call this exhaustive. You can call this anything you like. And the important part is we assign the never type to it. So we say never, and then we say, okay, we try to assign our location to this never type. Now what is happening here basically? TypeScript sees, okay, you have a branch for Paris and Zurich, but there is this branch for London, and if you hover over this, it shows you that it's also that it knows that in this location it can only be London, but you cannot assign a string to never because you can only assign never to never. So this will throw an error because you are not allowed to assign this. So, but as soon as I now add London in here, we can see the error goes away because TypeScript now knows the only way you can ever reach this default case is if location basically in this case is never, because it should never happen in this case. Now, many people told me, well, okay, but now I have this variable which is unused and maybe the linter does not like this. And so you can even remove this, and what you can do is you can use the satisfies keyword, and you can say location satisfies never. And what this means is that at this location, the location needs to satisfy the never type. So we can see if I remove this Zurich case again, we get an error again. So this way we have a compile time and runtime safety by using the never type. So I really use this in all places in my code because, of course, you can also do this with a switch statement. So if you, for example, would remove here Zurich, then we would again get a compile time error. And this way you don't have to sacrifice the compile time safety for runtime safety or vice versa, but you can have both, like your compile time safety with TypeScript, but also if somebody passes in something else, you can throw this runtime error. So we have now talked a little bit about this satisfies keyword. Now let's talk about infer. Now let's say we have a function which is an add function which takes two parameters and returns a number. Now we say a plus b. Now what we want to do is we want to have the return type of this function. Now what we can do is we can say type of add, and because we are here in TypeScript, this returns the real type of this function, not like in JavaScript where you only would get back a string function. But we don't really want that. We only want the return type of this function. So what we can do is we can use return type, which is also built-in type from TypeScript, and can wrap our type off. And now we can see we get back number. If I change this to string, it returns a string. But how does TypeScript do this? Let's create our own default return type, and we pass in our t, and now we can create like a conditional type again. We can say, okay, if t extends a function type, so if it's basically a function which takes any amount of arguments and returns anything, well, to start with, we will just say if this matches, just return any, otherwise return never. Now, if I say this is our default return type, we can see now that we just return any all the time because we have not specified what we really want to return. And this is where we can use the infer keyword. So we can say here, okay, if this t is in the shape of a function, please infer the type at this specific position and save it in a variable. I save it in the variable r. And then what you can do is just return this. And we can see now we get the number back. So if I change this to string, it will return a string. So infer is extremely powerful because it can just extract information out of any extends clause it is in. So we will see this in a later example. We will use this more, but this is like infer is really, really powerful and extremely versatile. You can use it in many places. And of course, TypeScript itself uses it also in many places internally. And where we now will use it is when we use recursion. So let's say we have a type here, and let's call this nested promise. And this is a promise inside a promise inside a promise, and in there is a string. Now you often have like these nested promise structures where you but you are really just interested in the real type and not in these promises. Now, because of that, TypeScript provides so-called awaited type, which you can just wrap your promise around, and you can see you get your string back. Now, how does TypeScript do this? Well, basically, it uses recursion. How would we do this if we would run like a normal function, a recursive function? We would have like our object, and then in there we would check what is the inner type of this object. If it's still a promise, we call our function again and again, and as soon as we find something which is not a promise, we would return it. So this is basically what we can do here. We say we have our we could do the same with, for example, an array. So let's say we have a nested array, which is an array inside an array inside an array, and in there is, for example, a Boolean. And now we see this is just a multidimensional array. Now let's build such a type like awaited, but for arrays. Let's call this unnest. We pass it in our t, and now we just do basically the same recursion what we talked earlier. We say, okay, if this t we pass in is an array, then please infer this generic type. Infer what type this array is in. So for example, the first time, this will return it's an array with an array, and in there is a Boolean. So, and then if this is an array, just call unnest array again with this inner type. Otherwise, return our type, because as soon as we have something else than an array in our inner type, we are interested in it. And now we can wrap this with unnest, and we can see now we get back the Boolean. So if I change this to string, for example, we get back a string. And if, for example, if you have a complex object, we get back a complex object type. Now, this is like a more simple way of using recursion, because what we do here is we just recursively call into our function. As soon as we find something we're interested in, immediately return it. But what we really want to do is we really want to create new types. So recursion can also be used to create really large new types from it. So let's try this. Let's say we have an RGB-CSS type here, and now this is not, we had this with a string, but now what we say is this is a tuple. And a tuple is nothing else than a fixed length array. So let's say we have an RGB tuple here, and we say 1, 2, 3, and this is perfectly fine. If I remove one element from it, then I get an error because it's only allowed to have exactly 3 elements. Now, just a quick side note to this, if you use this in TypeScript, you always could still use push or pop on it. So it's not really a fixed length array. To fix this, you can use read only, and now you can see push or pop is no longer available. So this is so you don't shoot yourself in the foot, just use read only. But the problem with this is, let's say you want to have like a fixed length array with 11 elements, for example, for a football team or something like that. Then you would have like count the elements yourself. And this is also, for example, if you want to have a tuple with 3 or 4 elements, then you would have to copy this and like this, and would say, okay, now I have to also add 4 elements like this. Now, wouldn't it be nice if there was a type in TypeScript, for example, which is called tuple? You can pass in how many elements you want, and you pass in the type you want, like this, and this will create this type for you. So sadly, this does not exist, but with recursion, we can create this ourselves. So let's do this. First, let us think about how would we do this in normal JavaScript. We would have like a tuple function where the first element is the length, the second one is the type we have, and the third one is like a collector, because if we recursively call this function, we then need to be able to add our elements to it. So we need to add the first time we iterate, we need to add the first element and the second one, and then so on. Now, what we can do here is, of course, we can do the same in our types. So what we say is we have the type here, and let's call this tuple. And the first element here, the first generic parameter basically we put in is the length property. The second one is the type. And the third one is our collector basically, which we say extends array. So this way we tell TypeScript, listen, this collector only allows elements with this type. So to start with, we just put any in there. Now that we don't have to put in everywhere an empty array to start with when we call this type, let's just remove this and say we assign an empty array to start with. Now, of course, this compiles, but we don't really get a nice type. So let's now go to the implementation. So how would we do this in normal code, in normal JavaScript or Java? We would say, okay, we check if the length of we provided here now the 3 elements is the same as our array length we have built. And this is exactly what we can do in types. We can say, okay, if the length extends the array, and now we can access the length of this type. Why is this? Because when I first saw this, I was also a little bit confused, but if you think about this, TypeScript needs also to know that we have how many elements are allowed in this array. So it also needs to like count how many elements are in there to check for this RGB tuple if this really has the correct amount of arguments. And we can exactly do the same. We can also access this property. So we can say, okay, if the length here is the same as our built up array, in this case, well, we just return our collector. Otherwise, we just call our function again because we are not done yet. So we call it, we pass in length as the first argument, type as the second one. And what we now need to do is we need to add another element to our collector. Now, of course, we can't use something like call.push because this does not work. You have to do it like in an immutable way. So what we can do here is create a new array, spread our existing elements into it, and add a new one. And now we're already done. We can see here on line 3, we now have created a new type, which now has 3 elements. And for example, what I could also do, I can say 4 elements. We can see here now we have 4 elements in it. Now, the only thing which is missing is the read-only. Now, you can't use read-only like this, but you can use this built-in function. We can use read-only like that. And now we can see we get the read-only prefix, so that it's also not mutable anymore. But what is the cool part about this is, beside being able to say I want 3 or 4 elements like this, I can say 3 or 4 elements, because this is like just a type. And as we can see here now, it creates now 2 types, 3 or 4. We can also go in there and say, okay, I want 3 elements, but what I also want, I want to have numbers or strings. And now even strings are supported. So you are not restricted in just like exactly one element, so like one length. You have multiple lengths. You can have intersection types or union types, and this makes it really generic how you use it. Now, one restriction in recursion is that TypeScript has a hard limit of recursion of 999 recursion. If you have like 1,000, we will see we get an error that the type instantiation is extensively deep and possibly infinite. So they have like this hard stop at 999. But I really like this approach, not only like for tuples, but for many other types, because it makes it really easy to reuse your code and don't have to like create these types on your own and maybe make silly mistakes because you did not count the numbers right or something like that. So before we now end, let's come to the last topic. And even if the other parts were maybe a little bit hardcore TypeScript, I think this one should really be used in many code bases, especially to make your primitives much more type safe. So let's say we have a variable here, email. This is a string, and you have me at type.rocks. Now let's say we have a function here, send email. This is an input, and we say send email to input like this. And now the problem with this is this send email only takes a string. So what I can do is I can say totally not an email, and I can run this, and we can see we get back. We can call this function without any problems. Of course, because this just takes a string. Now, what would you do if you want to validate such an email? Normally, what you would do is either you would create a check-in here, but I really like the single responsibility approach that the send email should only be responsible for just sending this email, not for checking it. So what we could do is we can say we have an isValid email function. We put in an input and we say okay, and return a boolean, and we say return input includes @ this is for us, this is good enough for us. So, and what we now can do is we could say if isValid email, we pass in this email, and what we now can say is send email, and could check it like this. Now, of course, the problem still remains that send email still is totally valid because, as mentioned, it's still a string. Now, wouldn't it be nice if we had something like this? If we had like a type email, and everywhere we use this type, we can be sure that this is really a valid email. So let's think about how could we do this differently. I've seen many times that for like these primitives, they made a type, for example, an object with one property called email or something like this. But the problem is that everywhere you then use this email, you have to unwrap it to access it. And let's say you have a function, and let's say you have a function log, where you have your string, which you pass in there, and you want just to log this string. Now, you can't just pass this email object in here. You always have to unwrap it to access the real string. So, but we can make this much better. What we can do is we can use branded types. So the first thing is we say, okay, we have this type here. Where do we want to use an email instead of a string? We say we want to use this here in this send email. And what you also want to do is in this isValid email function here, we don't want to return true or false. We want to return a type narrowing. What does this mean? This looks like this. We can say, okay, when this return here returns to true, resolves to true, we can say input is email. Now, what this does basically is we narrow the type. So what we say is, okay, the thing I put in there might be a string, but it's more than that. It's a real email. Now you can see nothing really changed because basically we told TypeScript, hey, if I put in here a string, then it's a string. So we have not accomplished anything. But what we now can do is we can add something to this type email. We can say, okay, this is an email, this is a string, and now we use an intersection type, so we say it's a string, but also has a property called brand. And when I first saw this, I was thinking like brand is some kind of special property, but it's not. You can't just add in anything you like. It's only important that you add a property to it. And I like to add the value the same as I call the type. And now you see something has changed. We see here line 14 does no longer compile, but line 11 to 13 still works. Now what's happening here? Basically, if we check the error here, we see that type string is not assignable to type brand email. Now, what's the problem and why do we see this error? Because TypeScript sees, okay, we pass in here a string, but but we want an email type. Where is this brand property? It's nothing to be nowhere to be found in this string. But where it is, why does this here work in this isValid email? Well, basically we tell TypeScript, listen, we have this string we pass in, which can also have any other properties we like. And if this return check here returns true, we narrow this type. So we say it's not only a string, but it also has this property brand. Of course, it does not, but it like restricts TypeScript to understanding what type of string we basically want. And this is why we can use it in here, in this isValid email function. But if I move this out of it, we can see here email is no longer an email, it's a normal string again, because only in this type guard, we know that it has to be a valid email. So, and the cool part about this is I was talking about this log. We can still call log email like this, because it's still just a normal string. But we can now say, okay, everywhere we really want this string to be in a shape of an email, we use the email type. In all other places, we just use the string type. Now, this, of course, restricts you to use this if case, so everything has to be wrapped in this if. What you could do instead is you can use an assertion. So what you can do is, let's copy this and say we have an assert valid email, and instead here of saying input is email, we say asserts input is email. And now we see this asserts does not want a return. What it really wants is an exception which is thrown. So we say if the input not includes at, throw new error, and we say input is no email. And the cool part about this is now that if we use this assertion instead of this is valid email, we can just say assert valid email and remove this if. And now everything which comes after this assertion is made sure of that the email is a valid email. So you, for example, can use this if you have an HTTP request and you get some response data, which is a string, but the name is like email. You can call this assert valid email function, and you can then be sure that everywhere you use this property after it, that it is a valid email. And so you don't have to like wrap everything in multiple if statements. You can only use like this block of asserts, and then be sure that everywhere you use your email in your code, otherwise elsewhere, you can be sure that this is a real email. So as you can see here now, if I run this again, we can see that everything goes through here. But as soon as I change this email to not including it, and I run this again, we can see I get an error and I will not go through the rest of the code. Another quick side note, this is another plugin I've written. It's called TypeScript Worksheet. You can use this in IntelliJ or in VS Code, and you can run your code inside your IDE. But I will show it on later slides. Now, before we end, I'd like to give you a brief introduction to something more crazy thing you can do. This is also on the GitHub I've shown you earlier. This is just like a sample of what you can do with all the things we have seen today without the branded types. They are like on its own. But in here we use map types, we use template literals, the never type, infer, and also heavy recursion. And basically what this does in around 30 lines of code is you can create like a an expression validator. This is always the hardest part of the talk. So it's this way you can validate if a string is a valid calculation. So for example, if we have a wrong position of the brackets and everything in here is not really a valid string in this case. Of course, this is highly over-engineered. You don't need this, but it shows really nice how recursion works, also with how you can use infer in much more complex behaviors than we've seen prior. So maybe give it a look if you're interested in such stuff where you do head and tail stuff. Yeah. So let's now go back. And before we go to the question, as already mentioned, you can go to typescriptworksheet.com. I really appreciate any feedback because I used Quokka earlier, if some of you maybe know it, but it does not support like Bun or Dino. So the cool part about this is my plugin supports both of them, so you can also play with Bun or with Dino and run your code right in your IDE. Yeah, let's now go to the questions. Yeah, connection lost. Let's see that I get the connection back. There are some other networks here. Yeah. Never type condition. Never type conditions. If I pass a dynamic string from user input, will the compiler force me to check it? So, if I pass a dynamic string, maybe I don't really get the questions. Maybe, yeah.
I can explain. So I was just curious if so that was kind of a compile check, right?
Yeah.
If a developer writes that static string in the code and check if it's correct, what will it do if I take a string at runtime but I don't know what it is? Is there any security barriers that are going to verify? They're going to ensure that I check it before I pass it to the function?
Only, I think it's, yeah, I think it is, but only at compile time, I think. So I think in the JavaScript runtime it will not, but I'm not really sure, I have to say. But yeah, not really. So if I remember correct, there's a difficulty passing a union type to a recursive type. I have to read this question again for myself. If I'm passing a union type to a recursive type, in my opinion, it should not be an issue. Maybe it is. It can be an issue. Yes, sorry.
I was explaining slightly further. Sorry, it's my question. It's something I came across while deep diving into a library called React Hook Form, which had point deep nested in recursive types. And if I remember correctly, when trying to had to do some funky syntax extending any to expand the union type so that it would work through the recursion properly. I just wondered if you'd come across that, and the syntax to kind of extend any to spread the union type seems not very nice. So I didn't know if you'd come across that.
Yeah, maybe it would be interesting which type of TypeScript you were using, because it got really much better, like since 5.2 or so. It really is better, but it's always, sometimes TypeScript is really powerful, and sometimes it doesn't recognize some stuff which you think, well, this should be easily understandable. So it always surprises you. But I think I would have to see the specific example to then check it. But thank you. Which plugins can you recommend? So I really like the ones which come with IntelliJ themselves. So the TypeScript compiler. They also will like rebuild the TypeScript plugin for IntelliJ so that they now use the TypeScript API much more. TypeScript compiler, now they are doing some magic themselves, but they will strip that out and then use the TypeScript API themselves. So I'm really looking forward to this. And I also really think that currently it's even better to work with IntelliJ than with VS Code. I know many people who work with TypeScript specifically in the front end only use VS Code, but in my opinion, IntelliJ provides a much better experience for developers. Are there any other questions? Cool. So otherwise, just send me something on LinkedIn or on Twitter. You will see it on the last slide. Oh, there is one. Oh, I had to scroll down. In the chess example, is it possible to generate a range of values for the type? Yeah, this is a question which comes always, but the problem is here you can do this, but only if you like start at, if you have like a range which does not have any empty space in it. For example, if you have 1, 2, 4, 5, then this will not work. You could do this, but it creates really large types, because it creates 1 for 1 and then for 1, 2, 1, 2, 3. So the types get really huge, and I would not recommend doing that. Maybe they will add such ranges, and then you could use it. But currently, I'm not really a fan of that. You can do it, and I've done it, but it's not really. It's not really creating nice code. All right. So before we go to the last slide, just a quick something that to ask from you is I think for all the speakers, you can rate the talks on your app, and it's really like the only way that we know if you like the talk or you did not like the talk, because otherwise it's really hard to improve it or to change things. So if you have some time left, just rate it, write a small review if you find it cool or not. Yeah, really appreciate it. And if you have any other questions, just write me on Twitter or on LinkedIn, or you find everything on my website. And if you need help with anything, also like on unpaid help, just send me a message. I would really like to help you. Thank you, and have an awesome lunch.